Let us look at these questions of radioactivity and see how we are supposed to respond towards these questions. The diagram below, the diagram in figure 6 shows a radiation emitted by a radioactive sample. So this is the diagram, a radioactive sample. This is the negative and this is the positive. So before even you go to the question, you need to understand if this is the positive, the one which is diffracted towards the negative, you should know which one is it from the characteristics of the radiations N. So M is likely to be alpha. Why? Because alpha is positively charged, therefore it will be diffracted towards the negative. N is beta because it is negatively charged, therefore it is diffracted towards the positive. Another thing you should know is the magnitude of diffraction. Alpha is very light, beta is very light, therefore the diffraction is very big. Look at this one and then look at this one. This is alpha, M is alpha, and the diffraction is very small because it is heavier. This one is lighter. It's lighter. So M is alpha particle. Alpha, we use this sign, and this one is beta particle. Explain what would happen when a sheet of paper is placed in a path of the two radiations. So what will happen? If it's a sheet of paper, then alpha is going to be blocked because alpha from the characteristics we learned, you should know that. Beta will penetrate through, will pass through because beta is only blocked by aluminum sheet. So M will be blocked. Will be blocked or be, yes, while N will pass through. Will pass through the sheet of paper. Yes. Another question. A radioactive substance weighing m kilograms took 1900 years for the original mass to reduce to 15 kg. Given that the half-life of the radioactive substance is 380 years, determine the original mass of the radioactive substance. So we want to calculate the original. I will take you through two methods. So the first one and then the second one. So determine the original. First, you need to understand here. We have, it takes the whole time is 1900 years. But the half-life one is 308. So we want to see how many half-lives are there in these years, the total time, 1900. How many half-lives are there? Because for it to decay from original to a half, that's one half-life. So we want to see, so we want to check number of a half-lives equal to the total time, 19 years, divided by 301 half-life. Yes, this one here once, here it will go 5. So we will have a total of 5 half-lives. So we have the remaining, which is 15 kg. So this is what has remained. 15 kg, yes, 15 kg has remained. Therefore, we want to go to decay to see the original, where the 15 that was left, where did it come from? So we just have the first half-life. This is the first. So we will do the, now we will multiply 2 because we want the original. If we have the original, we divide by 2, a half. But since we have the remaining, now we multiply 2. So 15 times 2, it is 30 kg. That's first half. Next, second half-life. It is 30 times 2, which is 60 kg. 1, 2, we go to the third one, third, a half-life, 6 times 2 is 120. Fourth, a half-life, because remember we must have the half-lives first, 5 of them, so that is 240 kg. And then the last half-life, the fifth one, it is 480 times 2, it is 240 times 2, which is 480 kg. So it simply means that the original mass was 480 kilograms. So suppose you are given the original mass, what do? We start 480 to 40 up to where we will have 15 kg, the remaining amount. But if it, now we go a half when we have the original, we divide by 2 up to the remaining amount. But when we have the remaining amount, we want the original, and you are using this method, you multiply times 2 times 2 times 2 up to the number of half-lives that you have calculated. I have 5 half-lives, so first, second, third, fourth, fifth half-life. But if that is difficult, now let us use the formula, or we can use this. There is a formula that we use that says that the remaining amount equal to a half times n times original amount, original mass. So we have remaining, it is a half times n. What is n? N is the number of half-lives. N is the number of half-lives. So let us substitute the remaining amount is 15 kg, remaining reduced to 2, meaning this 15 is remaining kg, equal to 1 over 2 raised to power n, and our n is 5 years, times original we don't know, we can put y. So use your calculator. 1 over 2 raised to power 5, it is 1 over 32. So that is 15 kg equal to 1 over 32. So 1 over 2 times y is 1 over 2y. We want to remove the denominator, times 32 both sides. So kilogram. So 32 times 15 is 480 kg, which is equal to y. So the original mass y equal to 480 kilograms. So you can either use this or this one to get what you want. State 2 uses of radioactivity in medicine. So you will give specifically for medicine, we have for agriculture. So if for number 1, radioactivity is used in sterilization of surgical instruments using the gamma radiations. After they have done the surgery, to remove the viruses or the dirty from the instrument they were using, they use the gamma radiations, and those they sterilize them, removing the germs or the nonsense that are there. So number 2, it can also be used to monitor growth in bones and healing fractures. Once somebody has his leg or a bone has been broken, they use the radiations to monitor how the bones are growing and the healing of the fractures. Complete the nuclear reaction below. This is a nuclear reaction. So 226, this is a mass number, atomic number. So it is forming a P with 88, and so you can see that this one is an alpha decay. Why? The atomic number is reduced by 2, mass number has reduced by 4. So 26 minus 4 is 22. Therefore, you complete by writing H, helium 2, 4, and that is all you need. State 2 uses of radioisotopes in healthy, and that's what we have done here. You can give others, we have done that. Distinguish between a neutron and a proton. So what would you say a proton is, and what would you say a neutron is? So let me distinguish that. So a protons are positively charged, while neutrons do not have any charge, and are neutral. So the neutrons are neutral while the protons are positively charged. Both of them are found in the nucleus of an atom. What is meant by a radioactive substance? What is a radioactive substance? A radioactive substance, this is a substance. This is a substance that undergoes radioactivity. In other words, say that a radioactive substance is unstable nuclide or isotope. Unstable isotope is able to undergo radioactivity because it is unstable, therefore it is radioactive. So a radioactive substance is unstable isotope which is ready to undergo radioactivity. So this is a substance that undergoes radioactivity because it is unstable. 288 grams of a radioactive substance decayed to 9 in 40 days. So the decay from 288 to 9 took 40 days. Determine the half-life of the radioactive substance. So we want to determine one half-life. How long did it take? How many days was it taking to decay for one half-life? So first we have the original and the remaining. So that is simple. 288 grams. So half of 288 grams is 144 grams. Half of 144 is 72 grams. Half of 72 is 36 grams. Half of 36 is 18, and then finally 9 grams. So this is the remaining amount and this is the original amount. So now you can see how many half-lives are there. There are 1, 2, 3, 4, 5. So now we have 5 half-lives. But it takes time from here to decay up to the remaining 9. It takes 40 days. So we know, so if it takes 40 days, so now we have 5 half-lives. So we can say that 5 half-lives takes 40 days. How many, what about 1 half-life? 1 half-life will take how many days? So it is 1 times 40 divided by 5, and this one will give you 8 days. So here it is 80 days, 80 days, 80 days, and 80 days. So 8 times 5, 1, 2, 3, 4, it is 40. Or 8, 1, 2, 3, 4, 5, 8 days. So 1 half-life is 80 days. Draw a label diagram to illustrate how alpha, beta, and gamma radiations can be distinguished from each other. You draw a source of, this is a source of radiations. This one is positive and this one is negative. So we know the beta particle is negatively charged. Beta particle is negatively charged. Therefore, it will be deflected towards beta particle is negatively charged. Sorry, remember that beta is negatively charged, so it will be deflected towards the positive. alpha is positively charged, it will be deflected towards the negative alpha. Gamma does not have any charge, so it will just go straight, and that is gamma. By so drawing this, you have differentiated them. (100) of a radioactive Pa, atomic number 33, mass number 912, was reduced to 12.5 after 81 days. Determine the half-life of Pa. So we have the final, the remaining amount. We have the days. We have the original amount. That one is very simple actually, because we have the original. So what you do just is just write the halves. From 100 we have 50 grams. From 50 we have 25. Use your calculator if you have a problem in maths. From 25 we have 12.5 grams, and this is the final. They need the remaining amount. So we have how many half-lives? 1, 2, 3. So we have 3 half-lives. This is the first, second, and third. But the entire decay takes 81 days. So they want us to find one half-life. What is the number of days for one half-life? Very simple. So 1, 2, 3. 3 half-lives takes 81 days. What about one half-life? Will take how many days? So it is 1 times 81 divided by 3, and it is 27 what? Days. So 27 plus 27 plus 27 will give you 81. And that is one half-life. Remember, it is 27, 27, 27. Remember that a half-life is a constant. You will not find here 27, here 28, here 29. No, it is a constant. This one decays by a beta emission. What is the mass number and atomic number of the element formed? So we have Pa33 912, which is, now we want to write the nuclear equation. An element is formed which is X. We don't know which element it is, but we know that it is undergoing a beta decay, right? A beta decay is plus E -1 0, meaning that the mass number will remain the same. So we will have 912. The mass number will remain the same. What about the atomic number? Remember the characteristics. Atomic number will increase by 1. Well, that one it is increasing. Will increase or decrease? That one is the most thing you need to know. Will increase by 1. Atomic number will increase by 1. Remember that. So that now this plus this, it is 33. This one. So what is the atomic number? Atomic number equal 34. Mass number equal to 912. Does not change. M grams of a radioactive isotope decayed to 5 grams in 100 days. The half-life of the isotope is 25. Now we have been given one half-life. We have been told that it takes 100 days. So the complete decay takes 100 days. But one decay from original to half, it takes 25 days. That's half-life. So what is meant by a half-life? What is the meaning of half-life? This is the time taken for a radioactive isotope. For a radioactive isotope to spontaneously decay or disintegrate to have its original amount or mass, original mass. The time taken for a radioactive isotope to spontaneously decay to a half its original mass is what is called a half-life. So calculate the initial mass of M of the radioisotope above. So we first get the number of a half-lives because we have that one. The total time taken is 100 days. One half-life takes 25 days. So this one gives us 4 half-lives. 4 half-lives. So if it is 4 half-lives and the remaining is 5, so it is 5 going to 10, going to 20, going to 40, going to 80. So this is 1, 2, 3, 4. There are 4 half-lives, so 1, 2, 3, 4. So the original mass was 80 grams, original mass. You can use the formula also, saying that the remaining amount equal to a half is to power n times k or y or x. Remaining is 5, which is a half times raised to power 4 times y. If you raise 4, this one will give you 5 equal to 1 over 16 y times 16 times 16, and y equal to 80 grams original. Explain why it is not safe to store radioactive substances in containers made of aluminium or made from aluminium. Remember, containers made of gamma will stop only beta, but it will not stop gamma radiation. Therefore, gamma rays would penetrate through aluminium sheets. State 2 factors which determine the stability of an isotope. Stability. So what determines the ratio? Actually, the ratio of the neutrons to protons is what determines one of the factors. So one factor is the neutron over proton ratio, because remember the stability equal to 1. So that's what one of the factors that depends. If it is less than 1, then the stability is not there. If it is 1, the isotope is stable. Another thing is the total number of the nucleons. The nucleons is the number of protons and the number of neutrons in the nucleus. Therefore, that's another factor in the nucleus. The total number of nucleons in the nucleus also determine the stability of an isotope. So, in other words, you can write here the total number of protons and the neutrons in the nucleus. That is this word stands for. State 2 differences between chemical and nuclear reactions. That one you should know. That chemical reactions are affected by environmental factors such as temperature, but nuclear reactions are not affected by environmental factors such as temperature. They are not. Remember, another thing you should know is that nuclear reactions produces a large amount of heat energy, while chemical reactions produces more amount or less amount of energy. Nuclear, chemical. So you also again remember that nuclear reactions involves protons and neutrons within the nucleus, while chemical involves the electrons in the outermost energy level. So those are the things you need to know. Some two elements are represented as X and Y. Mass atomic number is 8, 13, 16, 27 mass numbers. How many protons does X have? X, how many protons? Protons, remember protons equal to atomic number. So therefore it has 8 protons. X has 8 protons because this is atomic number. How many neutrons does Y have? Neutrons, remember mass number equal to neutrons plus protons. So if the mass number is 27 equal to neutrons we don't have plus 13 protons. So X equal to 13 minus 27 minus 13, and the number of neutrons is equal to 14. Y grams of a radioactive isotope takes 100 days to decay to 3.5 grams. The half-life of period of the isotope is 20 days. Find the initial mass of the isotope. Find the initial mass of the isotope. So we have the remaining amount is 3.5 grams. We have the total time taking. We have the half-life, one half-life. So one thing we can start, we are sure of, is the number of half-lives. That one is a sure bet here. So which is 120 days divided by 20 days, and it's going to give us 6 half-lives. 6 half-lives. So if the final is the remaining is 3.5 grams, we can now multiply it by 2. We multiply by 2, we get 7 times 2, we get 14 grams times 2, we get 28 until we have 6 half-lives. 1, 2, 3. Next is 56 grams. Next is 112 grams. Next is 224. So you just count 1, 2, 3, 4, 5, 6, and it means this is the original. This is where it came from up to here. Remember, when you are decreasing, when you have the original, you decrease by 2 by 2. When you have the remaining, you multiply by 2 by 2 to get the original. So the original is 224 grams. But you can as well use the formula. Remaining amount equal to 1 over 2 raised to power n times original y. Remaining amount is 3.5, which is equal to a half raised to power n. N is the number of half-lives. There are 6 of them. There is 6 times y. So 3.5 equal to 1 over 164. Half raised to power 6 is 1 over 64. Y. We multiply times 64 both sides times 64 so that we can remove this. So it means that y equal to 3.5 times 64, and that one will give you 224 grams. One application of radioactivity in agriculture. It is used in monitoring absorption of phosphate fertilizers. Another one is used in monitoring what? Monitoring photosynthesis. Monitoring photosynthesis and related processes. The figure below shows the behavior of emission by a radioactive isotope X. Use it to answer the questions that follow. So study the diagram. First, you can see this radioisotope source. This one is positive. This one is negative. So we have T and we have P. We have P. So explain why isotope X emits radiations. So an isotope emits radiations because it is unstable. So it means that the X is unstable. So a radioisotope which is unstable will always will undergo radioactivity to emit radiations. So it is unstable. Name the radiation labeled T. T, it is deflected towards the negative. So if it is deflected towards the negative, then it means it is what? It is the alpha. Because we know alpha is positively charged. So positive attracted to the negative. So T is alpha particle. Alpha particle. Arrange the radiations labeled P and T in an increasing order of ability to deflect by an electric field. Now that one, you consider this. Remember this is gamma. It means this is beta, because we have said this one is alpha. Look at the diffraction from gamma, and look at the diffraction here. The diffraction here is small, is bigger. Alpha particle is very heavy when you compare with beta. So beta deflects more because it is lighter. So that's what they want us to do here. Arrange the radiations labeled P in increasing order of the ability to deflect. Therefore, T going to P. So P deflects more than T in increasing order. Calculate the mass and atomic number of element B formed after this element here has emitted 3 beta particles, 1 gamma ray, and 2 alpha particles. So we start with our X, atomic number 80, 212. When we go to the right, we subtract for alpha. So alpha, how many alpha? 2 alpha, so 2 alpha plus gamma plus 3 beta, or we can write it 2 alpha is 2 H, 2 helium, 2 4 plus gamma plus 3 electron negative 1 O. You can represent this one like this. So what are we doing here? We know when we go this side, the mass number is for alpha, with the mass number decreases by 4 and the atomic number decreases by 2. So let us see here. So how many we are going to decrease? 2 for alpha. We are going to decrease the mass number. So let us write mass number 212. Subtract everything here. Subtract 2 alpha. 2 times 4 plus 0 times y, we call it y or whatever, a gamma that is, and this one is 3 times 0, that is for beta, because 0 times this. So when we subtract this, we realize this 212 subtract 8 for alpha. So the mass number is 204. Atomic is 80 minus this total. For this one is 2 times 2, which is 4, plus for y, it is for gamma, it is 0 times y, which is just 0. For alpha, for beta, it is 3 times negative 1. So this is negative 3. 4 minus negative is 1. So 80 minus 1 is 79. So this is the atomic number and this is the mass number. Write a balanced nuclear equation for the decay of this to be using the information above. Now that we have the atomic number, we have the mass number, now we can complete this equation. So there was B here. So now we have X 80 to 12 forming B 79 204 plus how many alpha? 2 alpha plus 1 gamma plus 3 beta, and that is the equation. That is the equation. X grams of a radioactive isotope takes 100 days to disintegrate to 20 grams if the half-life period of the isotope is 25 days. Calculate the initial mass of X of the isotope, of the radioisotope. So we have the total time taken for it to disintegrate, but we have one half-life is 25. So that one helps us to calculate first the how many half-lives are there. So number of half-lives equal to 100 days divided by 25 days. That one will give us 4 half-lives. 4 half-lives. So what is remaining is 20. So we can start there. So when we have remaining, we want to get the original, we multiply times 2 times 2 times 2 depending on the number of half-lives. Now we have 4 half-lives. 20 times 2 is 40. That is first half-life. First. Second half-life, because there are 4, 80. Third half-life, it is 160. And then fourth is 320. So first, second, third, fourth. So it means the original mass or initial mass was 320 grams. You can also use the formula. We know that the remaining amount is equal to a half times n times original mass. Remaining is 20 equal to a half raised to power n, and n is the number of half-lives, which is 4, times original, we don't know why. So 20 equal to, this is 1 over 16 y. Multiply both sides by 16. Both sides by 16. So this is 320 equal to y. So the original is 320 grams. Radium has a half-life of 1620 years. What is a half-life? It's very important. You should know how to define a half-life. A half-life is the time taken for a radioactive isotope or a nuclide, for a radioisotope and nuclide to spontaneously decay or disintegrate to a half its original or initial mass. To disintegrate to a half. So when 320 disintegrated to form 160, that's a half. 160, 80, that one is, so here we have this, one of them is called a half-life. This is another half-life, another half-life, another half-life. So a half-life is just the time taken for this one takes how many days? 25 days. Here it is 25 days, 25 days, 25 days. That is now a half-life. And I've also told you that a half-life is always a constant. 25, 25, 25. This makes 100 days. If 1 milligram of radium contains these atoms, this is 10 raised to power 18 atoms. how many atoms disintegrate during 3,240 years. But we know the half-life of radium is 1620 years. That is the half-life, but it takes 33,200 years. Now we can get the number of half-lives, which is the total 3240 years divided by 1620 years, and that one gives us 2.5 lives. So it has 2.5 lives. So 1 gram. So we are starting from 1 milligram. So 1 milligram will disintegrate to 0.5 milligram to 0.25 milligram. Why did I stop here? I stopped here because we have only 2.5 lives. First, second, 1, 2.5 lives. Right? Remember, this 1.5 life is 1620 years. 1620 years, making a total of 3,240. I have the whole total time taken for this amount to remain. So what the question is asking us, if 1 milligram is this, how many atoms disintegrate during this? So how many will disintegrate? Remember, this one is remaining. This one is called the remaining. Very important to understand that remaining amount. So if we want to know the amount that it is integrated, it is the total minus remaining. Very important to note. But we know that 1 milligram contains 2.68 times 10 raised to power 18 atoms. We will ask the remaining amount, or because it is asking, okay, let us get the remaining amount. The remaining amount is 0.25, so it is 0.25 milligrams will contain how many atoms? So it is 0.25 times 22.68 times 10 raised to power 18, and this one will give us 6.7 times 10 raised to power 18, 17 atoms. Remember, I have done for 0.25 atoms remain. This is what is remaining. But the question is asking us how many atoms disintegrated, decayed. So if we had 1 and we are remaining with 0.25, it means 0.75 were disintegrated. You should know that. You can also do directly like that. So we can now get number of atoms that disintegrated, number of atoms that decayed equal to the total, which is 2.68 times 10 raised to power 18, subtract the remaining amount, 6.7 times 10 raised to power 17, and this one will give us 2.01 times 10 raised to power 18. Another way you can do it directly. You will say 1 milligram equal to 2.68 times 10 raised to power 18 atoms. If this one were used or remained, then you subtract 1 minus 0.25. You get 0.75. These are that decayed. So you say 1 milligram equal to 2.68 times 10 raised to power 18. What about 0.75? So you should get this answer. The graph below shows the mass of radioactive isotope plotted against time. So this is mass against time. Using the graph, determine the half-life of the isotope. So how long does it take for 10 grams to decay to 5? Because 5 is half. From 5 to 2.5, that is a half. So you can see how many half-lives are there. It is 5 to 5 to 2. That's the one that you can see. So You can see from the graph 10 grams decays to 5 grams takes 8 days. Can you see that? So you can 10 to 5. So you go across and then come down. How many days are you seeing here? 8 days. So it takes, for it to decay a half to half, it takes 8 days. So let us see from 5 to 2.5, 2.5. You see, it is coming to 16. 16. So you can 16 minus 8 is 8. Therefore, half-life is a constant. So also from the graph, five grams decays to 2.5, taking 8 days. Therefore, a half-life equal to 8 days. Calculate the mass of isotope decayed after 32 days. So we have find that one half-life, it takes 8 days. But now we have up to 32 days. So we find how many half-lives are there. So number of half-lives equal to 32 days. The total divided by 8, 1 half-life. That one gives us 4 half-lives. 4 half-lives. So once we have the original from the graph, you can see the original is 10, right? The original is 10. So we can now see 10 going to 5 grams, going to 2.5 grams, going to 1.25 grams, going to 0.625 grams. Why didn't I continue? Because we have only 4 half-lives. 1, 2, 3, 4. 4 half-lives. You can see that. Therefore, you stop when the number of half-lives is finished. So if this from here is 8 days, this one is 8 days, 8, 8. So 1, 2, 3, 4. The total should be 32 what? 32 days. You should know that. Now the question is, calculate the mass of an isotope decayed after this. So you can see the mass remaining equal to 0.625 grams after 32 days. This is what will remain. As well as you can use the formula is saying that remaining amount equal to a half raised to power n times y times original. Now we want original, we want the remaining amount, which is equal to a half times n. N is the number of half-lives, there are 4, times original, which was 10, because we have original. So this is 1 over 16 times 10. This is same as 10 over 16. 10 over 16 is simply 0.625 grams. Now, most of the students will fail to get the last mark because they did not understand the question. The question asks, calculate the mass of an isotope decayed. They did not ask what is remained, right? So, if this one has remained, 0.625 has remained, and the original was 10, what was the amount that it decayed? So, it is 10 grams minus the remaining 0.625 grams. That one will give you 9.375 grams. This is the mass that it decayed. So you realize that most of them will leave the answer at 0.625, the remaining amount, yet the question was asking you to calculate the mass that it decayed. So you have to get the question right. A radioactive isotope X2 decays by emitting 2 alpha particles and 1 beta to form this. Write the nuclear equation for the radioactive decay, the nuclear equation. So we are starting with our X, which you don't know what radioactive decay is by emitting. So this one is the one that is decaying, and it is giving us Bi 83 and 214. So we want to get this, which decays by emitting 2 alpha plus 1 beta. 1 beta is that just E negative 1 0. That's 1 beta. So we have written the equation, but now we need to know what happened. What is the mass number of this, and what is the atomic number of X2? So we know that to going this way, it is in mind subtracting. So if already this one has subtracted 2 and then added 1, so subtract 2 and then add 1. So it means that this one was, so when we are going this way, we add 2 times 2, 4. So add 4 here. That is 87. 87 minus this negative 1. So this one is 86. Helium, it is 2 times 4. Right? Now, remember when we are going this way, we subtract. But when we are going back, we add. So 214 plus 8. Right? Will give us 222. But this one is 0 plus 0 minus 0 plus 0 is just useless. So the answer here is 222. And that is the atomic mass. This going the way. What is the atomic number of X2? 86. We can see this 86. After this days, 1/16 of the mass of X2 remained. Determine the half-life of X2. So 1/16 is remaining, so we start from 1 going to 1/2, going to 1/4, going to 1/8, going to 1/16. How many half-lives? 1, 2, 3, 4. Right? So we have 4 half-lives. 4 half-lives. But we know that it takes, the whole decay takes to 112 days. So we can say that the 4 half-lives takes 112 days. The question is asking, determine the half-life, 1 half-life. So 1 half-life equal to what? So it is 1 times 112 divided by 4, and this one gives us 28 days. So 1 half-life is 28 days. 28, 28, 28. When you add them, they should give you 112 days in total. These and these are isotopes. What does the term isotope mean? You should know that these are atoms. Isotopes are atoms of the same element with the same atomic number, but different mass number. A radioactive substance emits 3 different particles. Identify the particles with the highest mass. The highest mass is the one which is heavier, and I've told you that one is alpha. Alpha is heavier. Equal and electron is beta. Below is a radioactive decay series starting from Bi and ending at lead. Study it and answer the questions that follow. So we are starting at B83. We are going the way to 82 lead. Identify the particle emitted in step 1 and step 3. step 1 and step 3. So step 1, you look at the atomic number, what is happening, and the mass number. This is 210. So from 214 to 210, 4, subtract 4. 83, subtract 2, you get 81. Therefore, this one is alpha. Step 3. Step 3, the atomic number here is 82, here it is 83. Mass number remains the same. That one is beta. Because for beta, the atomic number will increase by 1. Atomic number will increase by 1. Mass number remains the same. So 1 is alpha particle, and this one is beta particle. Write the nuclear equation for the reaction takes place in step 1. Step 1, we can see very clearly this Pi, which is 214.83, undergoing the alpha particle to form Ti 81.210. Then you add helium because it has undergone alpha decay, one of them. That is all you need to write. Step 1 to step 3. So step 1. Now write those in nuclear equations in step 1 to 3, step 3 to 4 to 5, step 1 to 5, and then compare with my answers after you have done. And then you will do them using this chart here, and then check your answer using what I have done here. If a sample of cobalt has an activity of 100 counts per minute, determine the time it would take for its activity to decrease to 6.25 if the half-life of the element is 30 years. So 30 years. It is easy because now we have the initial or original, and we have the remaining amount. So we start at 1,000, going to 500, 250, 125, and then we have 62.5. So we have the final, we have the initial. So how many half-lives? 1, 2, 3, 4. 4 are half-lives. So we have 4 half-lives, right? But we know 1 half-life takes 30 years. 30 years. So if 1 half-life takes 30 years, how long will it take? Because the question is asking, determine the time it would take for it to the activity to decrease, so the whole time. So it is 30 times 4. It will take 120 years for this mass to decrease from 1,000 to 6.25 grams. 120 years. This one is for you. Check and answer this question. It is your homework. Hope you have seen it. Thank you.